Way back in Chapter 5, we learned about the normal model. We learned how to find probabilities, to find values in the empirical rule, etc. And what I want to do before we learn this week's material is to review some of that information. So instead of making you rewatch all of those videos, I'm going to give you a quick refresher. So again, what we had previously learned in Chapter 5 was the empirical rule, which we sometimes called the 68%, 95%, 99.7% rule, which help us to know what percent of values we can expect with 1 or 2 or 3 standard deviations from the mean. Finding percentiles in Statcrunch, meaning I have a Z-score and I want to find the p-value, which is the probability. Finding percentiles between two values. So if I had two z-scores and I wanted to find out between those two values, what is the probability? And then finding the z-score given a percentile, and so that was called z's in reverse, where essentially I was giving you the percentile, so I was saying top 10% or bottom 20%. And then we had to sort of reverse engineer the z-score formula to find the z-score. So let's just review some of what we already know, and we'll start with the empirical rule. And remember, the empirical rule is something when we have the normal model, and the normal model means it's fairly unimodal and symmetric. Then we can say that approximately, and remember the empirical rule was just an approximation, so approximately 68% of values fall within one standard deviation to the left and to the right of the mean. 95 fall within 2 standard deviations, and 99.7 fall within 3 standard deviations. So if we were to do this by hand, and I just basically copied over from when we learned this in Chapter 5, we had that ACT scores for students at Iowa State follow a normal model, and the normal model is given like this. And remember, when it's given in that format, that means the first value is the mean, and the second value is the standard deviation. And what I do is I start in the middle, and I place the mean in the middle, and then I add the standard deviation as I go to the right. So here I added 4.4 to get to 25.6. I added 4.4 again to get to 30. I added 4.4 again to get to 34.4. And then from, again, 21.2 going to the left, I subtracted 4.4. I subtracted 4.4. I subtracted 4.4. And that's all this is saying. So notice here I've written it a little bit differently, where I said if I started with the mean each time, this is 1 standard deviation to the left, this is 2, this is 3. As I go to the right, it's +1, +2, +3. It really doesn't matter which way you do it, as long as you're getting values from least to greatest using those two values. We also learned how to check our work with Statcrunch, which means we didn't have to do any work. I can just go to Stat, Calculators, and Normal, because this is a normal model. And again, to cheat, I'm going to change the mean to the mean given in the question. I'm going to change the standard deviation to the standard deviation given in the question. And when I do that, this little option up here, 68, 95, 99.7 ticks option comes up, and I click it once, and if you'll notice, I get the exact same values that I got when I did it by hand. So the trick here is to make sure that the standard deviation and the mean are rounded to whatever you want them rounded to in order to get the most precise answer, or the answer asked for in the question. So quite often we're asked to find things that are a bit more precise than just 2 standard deviations or 3 standard deviations, etc. And so in a question like this, where I'm asked to find the percent of students that scored 25 or better on their ACT, and notice 25 was not one of those values. So it's in here somewhere, and I want 25 or better, which means anybody to the right of 25. Now, I can't use the empirical rule to answer that question because I don't know what percent falls in this shaded region. And so instead what I have to do is I have to use my Z-score formula. And remember, the Z-score formula says take the observed value, which is usually just given in the question. In this case, that's 25, minus my expected value, which is always my mean, divided by the standard deviation. So notice here I've taken my observed of 25. Sometimes observed is thought of as what you are testing. So I'm saying what percent is 25 or better. So observed of 25 minus expected of 21.2 from the normal model divided by 4.4 from the normal model. And again, remember that we need to be smarter than our calculator. So if I put 25 minus 21.2 divided by 4.4, my calculator does this first, and you're going to get the wrong answer. So instead, I take 25 minus 21.2 in parentheses and divide it by 4.4. And that is where I get this decimal, 0.864. That is called a Z-score. And a Z-score is just the number of standard deviations above or below the mean. And so notice that would make sense. If this is 0 standard deviations and 25.6 is 1 standard deviation, then a value of 0.864 happening between 0 and 1 does make sense. Then I'm going to write my probability notation. And my probability notation says I'm finding the probability that my value is greater than or equal to 25. That is the same as the probability that z is greater than or equal to 0.864 because I just found that value to be true. And then I'm going to use Statcrunch to determine the decimal probability. So in Statcrunch, notice I'm using 0 for mean and 1 for standard deviation. And that means I'm putting in a z-score. And then I entered my z-score of 0.864, and I was very certain to make sure my probability is going in the right direction. I knew I wanted all of this stuff to the right because those are the people who did better than 25, and therefore I got my 0.194 answer. And so my solution, about 19.4% of students at Iowa State University scored 25 or better on the ACT. So I want to show you not only actually going into Statcrunch to find the solution based on the z-score, which I had a screenshot of on our last slide, but this is going to Stat, Calculators, and Normal. And remember, if I have a mean of 0 and a standard deviation of 1, I'm changing this to greater than or equal to because I want the values that are greater than, which means 25 score or more. And here I'm going to put 0.864 and I get 0.1937, etc., which is the 0.194 I used on the other page. Now what I can also do is if I'm not asked to find a z-score, or if I want to check my work. So don't just go straight to this, because if I ask you to find a z-score and you don't, I'm not going to give you the points for it. But if I go to Stat, Calculators, and Normal again, this time I can look at the mean of 21.2 and standard deviation of 4.4. And again, I'm looking for scores that are greater than 25. So notice the difference here is I've used raw score, raw score, raw score, compute, and if I compare the two, I get 0.1938, etc., and essentially the same thing. So they're really stinking close. So why aren't they exactly equal? Well, because when I found my z-score, I rounded to 3 places. However, if you're doing an assessment and it says find your z-score to 3 places, then I'm going to be looking for the probability based on your z-score to 3 places. So make sure you're not doing the cheat way or you're going to end up losing points in the long run. So let's take a look at a between question in Statcrunch. Again, we're using the normal model, 21.2, 4.4, and I'm trying to find the percentage of scores that fall between 20 and 32. So now I know I'm actually going to be looking at two different z-scores. Remember, to find a z-score, I'm taking my observed minus my expected over my standard deviation. And in this case, I actually have two observed values, so I have to find two z-scores. And when I do that, I get negative 0.2727 and 2.4545, which I've rounded to 3 places. And notice the way that I'm writing my probability notation. I'm saying the probability that x is between 20 and 32, that's how we would write that, is the same as the probability that z is between negative 0.273 and positive 2.455. So this one would round it up. And in the Statcrunch, because I'm using z-scores, I have a mean of 0, a standard deviation of 1. I'm adding my two values, negative 0.273 and 2.455, and that is what gives me my probability. When I write my probability in my work, I write it as a decimal. Then I write a sentence. The normal model estimates that 60.1% of ACT scores fall between 20 and 32. So again, if I have found my z-scores, I keep my mean at 0 and standard deviation at 1. I plug in the two z-scores, negative 0.273, positive 2.455, and then I get a probability or p-value of 0.601 or 60.1%. To check that, I can enter 21.2, 4.4, and then between 20 and 32, and notice I get essentially the same probability. The last type of question that we looked at was a Z's in reverse question. And remember, that's when I give you a percentage, and I have to pay very special attention to the context of that percentage. So here it says, suppose a college only admits students who score in the top 10% of SAT scores. How high of a score must a student get to be eligible? We're using a normal model, N 500, 100. And I'm using stat calculator's normal just as before. The difference now is that I am actually inputting the probability of 0.1, and notice I've chosen greater than or equal to, because what that did is create that this is the top 10%. Now why is that important? Because I want to use the z-score 1.2812 or 1.282, sorry, as my z-score, and I'm still using my z-score formula that says observed minus expected over standard deviation, but this time we're solving for the observed value. So what value must we have on our SAT in order to be in the top 10%? I need to score a 628.2 or better. So the or better comes from the fact that I could be in the top 5% and still be accepted. So again, how would I use Statcrunch to help me? Well, let's first show that if I went to Stat Calculator's normal and I had my 0 and my 1 and I changed this to greater than and I changed this to 0.1, that is how I came up with the value of 1.282 that I used on my last example. But again, it's nice when we can cheat a little bit, when we can check our work to make sure we're on the right track. And so to do that, I would put my mean of 500, my standard deviation of 100, and again, I don't want to input this value. I want to put that the top 10% and press enter, and notice I get 628.15, which is 628.2 or better on the ACT, just like I had before.